Hey, John Lee, he had a question if we are doing lecture. Anybody have his contact? No? He saw some leave, but they have an exam. Okay. Let me see if I can send him a. Anyway. So this is what we did last. Cyanohydrin formation. We saw how the CN group is attached. For my pen. And then this can undergo reduction, or this can undergo acid hydrolysis. Okay. Now, we're going to start another reaction. This is also part of the carbon nucleophile group. This is called the Wittig reaction, another W word, Wittig reaction. Now the reaction was the Wolff-Kishner reaction. So it's extremely important. They say we are only going to scratch the surface here, but for organic chemists, it's a vital reaction like the Grignard. Here the carbon skeleton is modified, and which means you can make the chain longer. Okay, you can make the chain longer. Ketones and aldehydes are converted to an alkene. Okay. We saw previously how there were reductions. We saw 2 or 3 reactions where this simply becomes this. Reduction. Okay. But this is, here the number of carbons are not increased or decreased, right? There's no change in the chain length. But if you look here, I'll give you the product. Okay. You introduce another carbon. Okay. And that carbon here I have 2 hydrogens. So I put 2 hydrogens here. And those 2 hydrogens can be replaced with something else. So you can make a longer chain. All right. So what's the product here? This is your reagent. It's called the Wittig reagent. We'll talk a little bit more about this in the next slide. But you don't care about the phosphorus part. You look at what's here. There should be a carbon, that's vital. Now, what do? You take this and then add another carbon. And then if there are hydrogens attached to that, then you just get this. And then from here, you can do any number of the reactions with alkenes, right? You can do a number of them, all the reactions that you know so far. Now, what is this reagent? Has the phosphorus. Okay, so they made it with the phosphorus. What is this guy? He's called an ylide. Like we need more new terms to learn. This is an ylide. And here, the carbon atom, that's another. Why is it like the Grignard reagent? Because remember, you made the carbon atom have a negative charge. And we were able to do a number of things with the Grignard reagent. So is the case with this. When you add phosphorus to the mix, the carbon, let me show you the structure here that we have. Oh, this was not exactly the resonance form I had. Okay, carbon with a negative. Resonance. I'll give you a second to get caught up. And phosphorus, remember, group number 5, it has 5 electrons. Phosphorus. What does a pH stand for? Phenyl. Okay, these are big benzene rings, phenyl groups. Now, okay. So carbon is negatively charged. Very rarely that happens. It happened with the Grignard, and now it happens with the Wittig reaction. Okay. So overall, this is a neutral compound, right? The plus and the minus, they cancel. But the carbon is negatively charged, and the phosphorus gets a positive charge. Okay, phosphorus is slightly less electronegative than carbon. So this is because it has phosphorus, and there are a number of ylides, but this is our first introduction to the ylide family, right? So this is our Wittig reagent. Got that? Now I will give you the structure of that on the test, so you don't have to remember that. But that's the ylide reagent. Next, we're going to see how this reacts with the carbonyl group. Okay, what's the reaction of this with the carbonyl group? So they place the ylide very close to the ketone. Okay. Now remember, it can happen with a ketone or an aldehyde. Right? So I can make this either way. Now this is going to undergo what is called as a 2+2 cycloaddition. Again, that's a type of reaction. There's, like a whole group or types of reactions that can be 2+2 cycloaddition reactions, just like SN2 and SN1. We saw a number of versions of it. So this is another type of reaction. We've not looked at this very much, but here's an example. So this opens up, okay, and this guy attacks here. See that? Okay, so this is like a nucleophilic attack, if you may think of it that way, okay, like a nucleophilic attack. And simultaneously, because the phosphorus has a positive charge, and as it comes close to the ketone, the carbonyl, the double bond is attracted to the positive charge on the phosphorus. Now, let's draw these guys out. I'm going to draw big so you can see it. Okay, so now this is a 4-membered ring. Four-membered intermediate. It can be isolated, so it's not very unstable. This is called an oxide, I don't have to remember it, phosphatane, another class of compounds. Okay. Now there are no formal charges on any of them, so it is quite stable. Now this is going to break down, of course. Let's see, what is our final product? Can you predict the final product here on the side? From what we did before, what is that product supposed to look like? You know the final product. You have this. And the carbon has 2 H's, so that's your final product, right? Alkene. So this 4-membered ring should break down to give your alkene. You see, there. So I'm going to draw that part. So how should that happen? Just 2 electron transfers, right? And then this guy, there. Okay, so it cannot be the most stable because these changes can happen. Are you able to see it? Or you like my black ink better? Okay. So can you draw the structure of the other product that will be formed? What happens to the phosphorus, the huge structure with all the phenyl groups? Okay. Let's go back and add all the phenyl groups. Double bond O. So oxygen hops on to the phosphorus fragment. And this is called, of course, you get the alkene. This is called the triphenyl phosphine oxide. Okay? Triphenyl phosphine oxide. Okay. So this guy is very stable. So this is going to push, towards the formation of the alkene and the triphenylphosphine oxide. All right. So once you have the Wittig reagent, the ylide, then it's a simple mechanism. 2 + 2 cycloaddition and some electron transfers within the ring, and you get the product. Okay. Now, before we continue, I want to do a sample problem. What chapter are we on? 19. Okay. Can we try this? Doesn't matter what size that is. What is the product? What would you do? I would look at this ylide. Identify the two groups that are attached to the carbon, okay? And then you can look at the resonance structure. So it looks like the one that you are familiar with. This is ethyl. Okay. Now, to predict the product, you don't have to show the mechanism. I'm going to make this a small green. I'm redrawing the reagents, that's all I'm doing. Now that, or just the oxygen, is replaced by this. Okay, if you go through the process, look at the mechanism. Okay, that oxygen is replaced by ET. See that? So replace the oxygen with this. So to predict the product, that's all you do. And then from there, you can have different reactions take place with the alkene. Got that? So remember, the synthesis part or predicting the products is not difficult. You should know that the oxygen here is replaced by that carbon and all the groups that come with the carbon. And this double bond is retained, still an alkene, or a double bonded compound. Got that? Okay. Now, how do you make the Wittig reagent? We'll look at it quickly. What can you use to make the Wittig reagent? Just like how do you make the Grignard reagent? Okay, similar to that. Now, if you want that, then you use a CH3Br. Okay. For that carbon, if you want 2 hydrogens, then you simply use a CH3Br. If you want something else, then you have to modify these hydrogens. And then you treat this with this is called, make room there, because it's got 3 phenyl groups, triphenyl phosphine. Okay. Phosphine, you see this is like ammonia, right? If it had H's, this is phosphine. Okay. So when all the hydrogens are replaced with phenyl groups, then it is triphenyl phosphine. Making sure it's recording. Okay. So CH3 I'm just going to draw 3 lines from here on. Now, you have a methyl halide, and you have a nucleophile. What reaction can happen? Methyl halide and a nucleophile. Yeah.
SN2.
SN2. How do you know that?
Because of the substrate and the nuclear.
Very good. And it also says here, the first step is SN2. But what you're saying is correct. This is a nucleophile. Right? So this is CH3B. It uses its lone pair. So this guy gets a positive charge. Okay. We still haven't made the reagent yet. We need to go from here to here. what should we do to go from here to there? What is removed? And H is removed as H plus. Okay, and H is removed as H plus. So we need a base. We'll see what kind of a base you need to remove. I'm sorry, I said as H plus. It should be removed as that is right. It should be removed as H plus. Sorry, I was tripping. Proton transfer. Okay, but under the conditions used, you cannot use any old base that you like because of all the other reagents present. Look at the base they use. Butyl lithium. I'm going to show the structure for butyl. Halide plus. Okay. This is like CH3 and GBr, something like that. Okay. These are organometallic compounds. So this is the base that is used. Now, the first step, as we know, is SN2. Okay, let's mark that. This is SN2. So your substrates must be either primary halides or methyl halides, something that is less sterically hindered. You need primary or methyl halides. Okay, this looks complicated because of the big structure of the phosphorus, but if you just put 3 lines instead of showing the pHs, it will be less cluttered and easier to understand. Okay. So because HWE, these are extensions of the Wittig reaction, we don't have to worry about. Okay, again, a named reaction, 3 different scientists. Now, if you look at this, if you want this CH2 there, then you need to use CH3X or CH3Br here. Now look in here. You want a carbon attached to these 2 groups, a methyl and an ethyl. So what is your halide going to look like? This is your halide. But what type of a halide is this? This is secondary. So which one you think is possible? Route 1 is more feasible. Since the halide is since there is a methyl halide and not a secondary halide. See that? So there are some restrictions. Okay. There are one or two things that I need to talk about. The Wittig reaction, like look at synthesis and stuff. And then we have one more reaction, which is the Baeyer-Villiger oxidation. We're just going to look at how to predict products. And then I want to do some sample problems for all the reactions we've seen. And I'm going to do that on Monday, because I know you have studied for the quiz and you're still trying to retain information. So I'm going to stop here, and you will see a homework, a handwritten one, that'll be posted for this chapter. Okay. And then Wednesday, you will take the mechanism quiz. Tuesday, you'll have the lab quiz. I'll post all of those that we talked about. And so Monday, I will finish this, do a few sample problems quickly, and then I'll start chapter 20. Chapter 20 has like 40 slides or so, okay? And then the amines chapter will have 40 slides, so, and that'll include naming and acidic characteristics, basic characteristics, so it'll be more qualitative as well, and a few reactions. And then when you write up the esterification lab, that mechanism, will be reviewed again for the carboxylic acid chapter. Okay, so they're all going to be related, but concentrate on what you have for now and for this weekend, and spend some time in prayer as well, and have a good Easter. All right, any questions? No, everybody's pretty worn out. And I've emailed Rebecca and Michaela about changing the link, but you should have everything to do the unknown compound. Okay. And if you all have questions, the questions are going to be very unique because each of you have your own compound. Now, when is that due?
Tomorrow.
Okay. Do y'all need more time? Yeah.
Yeah.
Okay. So when do you want that turned in? When do you want that due? Saturday, maybe?
I think Saturday's fine.
Saturday's fine.
I just
Okay.
have to look at the template.
Huh?
I haven't looked at the template yet. I just got the update, so
Yeah.
it's fine.
Okay, Saturday. I'll make it due Saturday. Okay. All right. Hutch has already finished it, so he's not worried. All right. Okay, guys. I will stop the recording now.